Det gick bra, han fick alla rätt. Ja. Jag har lite möte här nu. Bye bye. I thought I had muted there. Okay, anyway. Let's continue here. Alright, we were doing the token debugging stuff. That's right. And then now there's an issue with what? We kind of left off last time with no... Yeah, just in the middle of something. And trying to get back in here, so... What is going on here? Okay, so we're cloning the context stack, which fails because of some weird error that I've never seen before. Mem copy arguments alias. Okay, I guess I will Google on that, because I have no idea what that means. Source and destination overlap, right, but how? Okay. And maybe not, actually. Yeah. It might have to do... Oh, wait. I know what's going on. As usual, when you get weird errors like this, it's the allocators that are different. So, where's the Lexer snapshot here? Here we're using this allocator to deal with the context stack. However, the context stack is initialized using the arena child allocator. So when we're dealing with the context stack, we have to use the arena child. We have to use the same allocator. Maybe it's better if we just make it managed then, so we don't run into this issue. But the managed array list will get deprecated. Okay, anyway, let's just use the correct allocator every time. Wait, is it managed? Append bounded. Oh yeah. That doesn't need an allocator. Okay, here we go. So this should be arena child allocator. And I don't know what the reason is to why I did it like this, but hey. Okay. Still issues. Okay, I think we're line 3 and line 4. Yeah. Invalid enum value again. And we're trying to log something here. Peak token F. So this is apparently invalid now. Wait, what? No, Lexer 703. So it's still invalid. Just like it was yesterday at some point. Which means that you give us the wrong thing. No, okay, so we don't, it's not next, because then we would have gotten this log. I think. Or maybe not, actually. We have to enable the logs here. Okay, no, we don't get next. We get peak token and then tries to do the peak token, but it's empty. Okay, I have to, I'll be right back. 1 second. There we go. Yo, Zevlins. What's up, what's up? Okay, so we don't get the next message from the Lexer. We just look at the peak token, which means that we have... Is it early or late for you? You're on time finally. All right. 3:51 a.m. All right. Wow, that's, you know, that's like either it's very early or very late. Don't you sleep? Very late and up since 8 a.m. Oh, shoot. Alright. Yeah, I can't do that anymore. It gets so messed up. But all the power to you. Let's see. Next. Okay, let's just try and fix it. So next, when we get this message, that means we're consuming the next token in the Lexer. When we try to peek something here, that means that, and we didn't get this next message just before, that means that we still have peaked tokens in the buffer. So so that means when we do like the peak here, log something something. Where is this call from? Lexer 703 parser. Oh, it's just a bug peak token. Oh, so we're just trying to peak this one? No, wait. Parse pipeline 450. No, 734. So we're trying to pick this one, and apparently that fails. Okay, are we restoring a snapshot just before? Yes, we are. But we seem to do that anyway here. No, wait, that's taking a snapshot. Took snapshot, but that wasn't restored. Is that okay? That's the only one that's restored. Okay, so let's do this. Let's go to the Lexer and we'll make another test, or maybe we'll add this here. No, let's just make another test. So it's easier to think about. Yo, I'm Borshak, by the way. How's it going? I'm just trying to manage my windows a little bit there. There we go. So don't get distracted by other things. Okay. Lexer. Yes. So the scenario we're looking at now is basically we peek stuff, we snapshot, we restore. Let's look at a specific thing here. With snapshot, we access a peaked token and we consume it. And then we pick 2 tokens. And then we restore. So we consume. Okay, let's try consuming. Peak. Next. And then peak again. Let's do like 4 and 5. Okay, we get this like leaks here. However, all tests pass. Okay, they pass. But if we try to now actually, let's peek here. No, but we are doing this though. So took a snapshot with some kind of peak token. We're peaking, we're taking a next. We're peaking some more, we restore. We consume a next directly after. Okay, so let's do next here. One fail. Man, I really wish I could fix this constant stack clone. Wait. Yeah, I think that's what we need to do. Okay. No? Okay, maybe it's in the restore that it's double freed, leaked. Clone 131. Oh, it's in restore. This one gets leaked. And that gets double freed. Okay. No, but how? Oh, because we're never... wait. 6, 7, 9... No. 8, 7, 5. So we give it a snapshot. We clone it. We restore the Lexer here. Okay. So this is the snapshot Lexer that we clone. The Lexer then gets overwritten. What about the snapshot Lexer? Okay. Good. Finally, that gets fixed. Now, we get a seg fault. Okay, now we're getting somewhere. Lexer 89, get last or null. On context stack. Of course. From 8 to 7. After the restore. This is basically the first restore we're doing here. Okay, good. It's not great, but it's good. That we can finally get to the issue here. Or like we can finally test this. Okay, and then here we get immediately a seg fault. So let's go through this one by one here. We create a clone there. We just grab that, restore it. So at this point, self.lexer is restored. And that's why I'm keeping it here. Because here we overwrite everything in self. But here we restore the lexer to this. Which is kind of like a copy. I'm not sure if the arena is like fully copyable, to be honest. The allocator is. What about this state? What is this? It has first a node. That should be copyable. So we should be fine there. Yeah, and then it's just primitives and pointers. So we should be fine. The only thing I'm worried about is the arena state. Right, okay, I see what's going on. So here we're restoring lexer. Now the arena has been kind of updated. However, no, but yeah, this still points to the same lexer. So that should be messing with the same thing. Wait, when we do this, do we overwrite this? We need to kind of clone it, I guess. Actually, okay, yeah, we need a lexer copy like this. Because what's happening is we have a pointer to the lexer here, so that points to self.lexer, right? But when we do this, we overwrite self.lexer with whatever in the snapshot, which is not the way we want to do it. And then we lose the data. So we have to, before we do that, we have to copy whatever in lexer. Then we overwrite ourselves. And then we restore the lexer with the copy. There we go. Hopefully. This is never mutated. Fine. Okay. Okay. So now we get this expected, and I believe I understand why. It's because the last test here we changed a little bit on what we peaked. So basically here we're saying we peak 3, peak 4, then we consume 1, peaks 5. So that means we should have advanced, well, we should peak 5, but then we restore back to the beginning, and then we consume 1, peak 5. So the peak should be 5 elements long with the first one removed. So we should remove this. And then we have an identifier. So this one is removed. We have an identifier, new line, identifier, and then start string start. And then we have like, let's do, I think we have a string text. And then we have a string interp start. How many is this? 1, 2, 3, 4, 5. Let's do one more. This should be an identifier, which is the A there. Okay, and then we increase this by 1. There we go, all passed. Nice. Okay. Let's disable logging. And there we go. Finally. Okay, let's see if let's see if it works with the Lexer now. Or the parser, I mean. Alright. Oh my god, it works now. We get all these ASTs. Holy shit, it's a lot of... Oh yeah, that's... We have a lot of things in here. Okay, cool. Let's disable the document parser logging thing. Now we should only get the AST, but we do get these. I'm gonna do like self Lexer log instead. Cool. Don't we have identifiers? Maybe we know. Okay. Well, that works. Does it work now to run it? No. Leak memory, okay. Well, it works to run. Wait. S plus something else. Did that work? No, something else. String concatenation works. Finally. Cool. Let's just see if that works. Okay, the more we add, the more leaks we get, so... But yeah, it works. Awesome. Cool. I mean, technically, we could have also interpolated this, so basically this would be the same as doing this. No, wait, not S. Actually, it's even more powerful. Or, I mean, okay, if you want to be very like this. That should be the same thing, which we already, you know, support. And we don't get leaks. But... So, should we remove this feature? I don't know. No, I think it should be like convenient. We just need to fix the leaks. Good, Sevlins. It's fun when it works. And it can be frustrating a lot of times, but it's so nice to get rewarded by just persisting. Alright, let's see if we can fix these leaks here. Interpreter, evaluator, to on slice. Render string literal. Evaluate assignments. Okay. So it should be like a 748. Oh, this one. Right, so we have this buffer of U8. So this is basically a dynamic string. Hello, Metallics. Welcome. Yeah, a dynamic string. How are you doing? And we do things here, and then we do that. We should move it to whatever we're doing here. It's moved into the RC. And then apparently that RC never gets deinitialized properly. I'm doing great. I finally got past some hurdles here. Let me show you here. Now this works here. So we're moving forward. String concatenation works. But I mean, in case of this, I would probably do something like this instead. But whatever. It's nice to have the option there, and it does make sense in like a scripting language to be able to do something like this. It's gonna be interesting though. Like this will enable a bunch of pitfalls though, like with, you know, adding a number and then trying to add a number on that, you know. Yeah, plus equals, I mean, now that we have equals something plus something plus, that is kind of the foundation of that. So to implement plus equals should be trivial. We just need to add another operator token and a parsing for that. It could be a modification of the reassignment. Actually, what is that expression? Well, let's finish this here first. Okay, it was kind of tricky. Okay, this kind of the weird thing about me here. I always think that that sounds easy, but then it's like, well, there's all these kinds of weird stuff you have to think about. That you don't like think about before. It's like, yeah, but that sounds easy to do. I should learn my lesson. Assignment. Yeah, that just goes back to the whole pipeline. Why is this like... Is it the reassignment? That's an issue. It would be nice to know at which point this was actually done, because I would assume it's the first assignment that gets like yeah, reassign to a new value. But that is not an issue in itself. Like if we do this and this is also reassigning. We can do this how many times we want, and I never got an... nah, there's no leaks there. Oh. Oh, I see, because I used like S here. Okay. I thought it was gonna be like the same thing. But basically, yeah. I wonder. Oh, okay, this is another test. What happens if we reassign it to itself? Will this be an error here? No. Good. I added this feature on level IR. I have no idea how to add it on a level AST. The plus equals. Okay. Well, it's gonna be interesting when I get there. I thought it would be trivial if we have like the building blocks of it, but maybe not. We'll see. It could be differences how we design our ASTs and parsers and stuff. Yeah, it's just gonna be like, how do we organize? Like we have this, I have this assignment node, and we could include here like maybe like an operator here, like an optional operator that would you could modify the assignment. That could be one way of representing that, because it is kind of like an assignment mixed with another operator, so it makes sense to put it here to me. Okay, so I don't think it's the assignment per se that's the issue. I think it's the evaluation of this that's the issue. Let's bring this, remove everything, and then we'll do like const s equals, or even just echo hello plus yo. Will this work though? Okay, so we don't allow, well, I think we could do this perhaps. No. So the pipeline parser is a little bit special. We should enable this, to be honest. We should enable you know, you can't even have let's say you have like hello, you can't do this either. It only wants strings. So the pipeline parser is a little bit special. I think I want to change that though, because I want consistency in the language. It's not, yeah, definitely consistency. But okay, let's do hello plus yo. So just declaring this variable should give us, oops, a leak. Yes. Okay, so it's definitely the evaluation of binary, evaluating left and right. If they are strings, we create a new one, but then we never release these. Okay, that's the issue. Oh. So you need to be var. Fine. Sometimes I dream about cheese. Hello, Blue. Back to the philosophical discussions. Okay, now we get no leaks. And then we echo that. There we go. Problem solved. Hey, reference counters to the rescue. Alright, cool. Okay. So, yeah. Very simple hello world example. That's always nice. No, it's fine, Blue. I think it's good with a little bit of variation. I do love talking about programming, but what is memory leak in your programming language? Never released memory isn't a leak, I think. Memory leak is memory you can't access. More accurate definition. I mean, yeah, it's just good to. I don't know. The thing is, the zig allocator detects memory leaks. So if I'm using the zig, allocator to allocate everything in the runic program. So if I had a string here, hello plus yo. Now this was before a memory leak, so every time you did this, these two strings were kept in memory. And they never got released. So if I kept reassigning this to, or basically keep doing concatenation. Every time you do a concatenation, the strings that you concatenate are never, they are like copied, or basically they are never released, basically. So over time, if you have a loop or something, that would be like run out of memory probably. But the thing is, we should have a better, there should be a better memory allocation system, because we're using, actually, I don't know what allocator we're using right now. But for example, if you use an arena allocator, or any kind of allocator, I don't know if there's an allocator in Zig that actually, when you freeze something, it will get how do you say it? It will get available again. So kind of like this. So I know that the arena works like this. Let's say you allocate something. So this is like, we're allocating a piece of memory here. So this is the sort of memory, this is the, so imagine this is like a line of memory here. And this is like address 0 and so on. Address, so let's say this is like 3 length, so this is like address 3 or something. And B gets allocated here. This is address. Well, we don't need to have lengths. Let's just do like 0, 1, 2 is not 2 is not allocated. So I'll just do this, and then so on. So let's say we have an allocator that has the first, because the allocator works like the arena allocator works like, it has a region of memory that is like allocating. I think it has like pages. So it allocates a page, which it puts things in, and when that page is full, it has to allocate another page, and then it just keeps on putting things in there. But when you allocate a bunch of stuff, and let's say we allocate another thing here too. So now C is allocated here. Now, if you free up 2, it will look like this. And the arena allocator works like this. If you free up the last item, which was 2 in this case, you can actually reallocate that same area now. So, but if we allocate here, and then we free the 1, we free 1. Now you can't actually access this memory again. So you can't, like, if you allocate something else now, it will actually be allocated over here. So if you free this up, you don't actually get that memory back. You have to like free in the reverse order that you allocated in order to do that. Yeah, and I do want to have that also metallics. Like, I want to be able to have a loop where I can allocate as much as I want, and then, you know, keep going forever, basically. So I do want to have kind of like, you know, I think that I need to implement some sort of garbage collection in order to be able to do that, because otherwise the memory is gonna leak. If we're using this, I don't think Zig actually has an allocator that can do that, if I'm not mistaken. I could be wrong, but it's either that or we always do like a, it would be nice, or like a syscall every time. But it would be nice if we could have an arena like this, but if you free something up, like a modified arena, where if you free something up, it gets available again. We could even have a modified arena that works with reference counters, maybe, so we can keep track of all the reference counters, and then we can detect leaks from those, and maybe like inspect how many references and stuff we have and stuff like that. Yo, Hoffman, arena allocators are best for shared lifetimes. I need memory for the whole app lifetime. Can be leaked. Frame lifetime, request lifetime, etc. It's super handy for grouping lifetimes. Right. Actually, I actually used that in my, I think, I'm not sure if it was the game or the editor, but basically it's a loop-based, you know, every frame. So a frame allocator, basically you allocate a bunch of stuff in one frame, and then it's in an arena. So you just allocate whatever you need, and then at the end of the frame, the arena gets deallocated, and then, so it only lives for one frame. Yeah, that's really nice. And also it keeps the capacity, so the next time you can allocate stuff, we don't have to do a syscall to allocate. It keeps the same area of memory available. So it's very fast and useful as well. Yeah, I have to create garbage collection. Yeah. I think well, we don't really need an arena, I guess. We need something that just works with kind of like pages and stuff, maybe. I don't know. Actually, there is a thing in Zig called the page allocator. I haven't looked at anything other than the like arena allocator in more detail. Actually, it's heap. So we have the page allocator. There also is page allocator, this one. And operating systems, on operating systems that support memory mapping, this allocator makes a syscall directive for every allocation and free. Otherwise, it falls back to the preferred signal for the target. If we're on plan 9, we're using this. Okay. So this one. I wonder if Runic works on plan 9. Actually, does Windows support plan 9 like in the VM? I've used it like one time long ago. No. Well, it's not in Microsoft Store. Okay. Okay, so how does this work? We have like, so let's look at alloc maybe. You do a map. All right. Okay, so heap page size, I guess this is like operating system known. Standard options page has been. Oh, so you can actually tell it what it could be, like in the compiler options. Or what is this? I think so. Standardly wide options that can be overridden by the root file. What? I never knew this. That you can do that. Has declaration, standard options. Whoa. I never knew this. This is cool. It's kind of magical, but I mean, I guess they kind of have to do this because it has to be comp time known. Alright, well at least it's like possible. You can change the log function. Alright. Yeah, okay, so that's how you could override the log function. So you can actually, you know, if you're using standard log, then you can override the log function to do whatever you want. That's really cool, actually. So you have to implement this function. Wait, does it always print the standard error? I guess it makes sense. Okay, anyway, we're looking at the allocators. But this is kind of cool. Page min max. You can override this function. Okay. Overrides default position, determining those page size at runtime. Format max depth. Hello, Fostax. This is very impressive. What is your background in software engineering? Do you have any low-level exploitation experience? No, nothing like that. Okay, well, basically, 10 years of web development experience, but I've always been like interested in programming. So before that, I was self-taught in C++ and a bunch of other languages. And yeah, I just love learning new languages and exploring and making all kinds of projects, basically. But hacking has never really been one of my interests, to be fair. Like, or to be honest. I mean, it's interesting in its own sense, but it's not really something that I want to spend time doing. Like, it's good to know some of the like some kind of some, you know, if you're gonna make a product that's gonna be secure, of course. But yeah, it's not really my cup of tea. I like building stuff, but I don't like to think too much about the security. But it is interesting. I mean, some of the things you hear people do is crazy, but that I could never, you know, figure it out. But knowing a little bit helps a lot. I am interested in how the low level stuff works, even though I'm not in like an exploitation sense, but more like, okay, this is how this computer actually does things, you know. All right. Anyway, okay, so we have the page thing. I just want to explore how this works a little bit, because garbage collection is something that we need to do. Red teaming is cool in concept when you realize it's more reports than pen testing. Unless you do bug bounties and stuff, it hurts. Right. Okay. Yeah, I've never been in that world, so I would rather build things. That's my cup of tea. Well, thank you, Faust. I appreciate it. Socket programming stream. Not sure, like, what kind of project I have right now that would require socket programming. Like, Runic wouldn't really need it because we're kind of using like other executables to do that kind of stuff, I guess. Like, there's not gonna be like native, you know, HTTP library that you're gonna be able to use. You're probably just gonna use, you know, the point of the language is not that, but and then in the game there's really no socket things going on. Maybe for I don't know if we're gonna integrate to Steam or something like that. I don't know, but I/O multiplexing, we scale a single thread to the moon. Building safe software is key to longevity. I mean, yeah, of course, it's important to have security in your products that's supposed to be used by other people. But what I'm saying is that I'm not super interested in like learning about the security, like learning about, okay, these things you need to do in order to make a secure product. I would rather kind of hire someone else to do it, maybe. Because I don't know. I think it's more interesting to me is actually building the thing and not like protecting from hacks. It just feels like it's kind of different worlds, but they also, of course, they share the same domain, but okay, so we have a page size. And okay, let's look at Linux. Okay, so Windows has this. This is the Windows. Okay. Alignment length. Align forward. Round an address up to. Okay. So where are we? N? What is N? N is the length of the desired thing. Pointer plus align -1 and inverse align -1. Ah, I see. Okay. Plus. Is plus correct? Yeah, I guess maybe. C alignment macro. Okay. Yeah, because if you add that, you would just remove the and, I guess. Yeah, plus. Okay. Yeah, because it's a numeric operation. Because a line is expected to be power 2. Alright. Yeah, okay. Yeah. It makes sense, you know, if you're... I mean, it's not that... You can see the thing they're doing there. They're removing the alignment bits. I guess it would take a little bit of time to understand the full... I would have to learn what is that is doing by some examples. So find a binary trick. Any power 2 minus 1 will flip all bits below it. Below the bit that was flipped to give the power of 2. Yeah. Because any power of 2 is just 1 0 with a bunch of zeros. And then -1 will be... One will be flipped to 0 and the other one will be flipped to 1s. To the right of it. Yeah, so this one, I guess this is what's doing that. See here? Except a little bit different. I think you can actually have that. You can probably have that expression in here as well. If the types are the same. Okay. So this ends up in some memory. Okay, so it runs it up, right? So it's just the size of the thing to fit in a slot, basically. Max drop over alloc, slice, POSIX mmap. Okay, but now it's using a syscall here, so I'm not super familiar with these ones. Because we're just calling this every time we want to allocate something. What is this? File descriptor, -1. Flags, private, okay. Protection, read, write. Length is over alloc, okay. That is the pointer. Next mmap adder hint. I don't know. I wish there was more documentation on this allocator so that it could kind of explain what's going on. Because I am not. I'd have to go and read now what this is doing here with these options and everything. I mean, there is the mun map. It's kind of funny. Man or mun means mouth in Swedish. Mouth map. M-un map. Okay, I see what's going on. Right. Okay. Creates a new mapping in the virtual address space of the calling process. The starting address for the new mapping is specified in adder. Okay, so we're kind of deciding ourselves what the adder is, but we're in a virtual space, so we could technically put in like 0, I guess, to have the first one. I don't know. The length argument specifies the length of the mapping, which must be greater than 0. Of course, yes. If adder is null, then the kernel chooses the page-aligned address at which to create the mapping. This is the most portable method of creating a new mapping. If adder is not null, then the kernel takes it as a hint about where to place the mapping. On Linux, the kernel will pick a nearby page boundary, but always above or equal to the value specified by this. Okay, and attempt to create a mapping there. If another mapping already exists there, the kernel picks a new address that may or may not depend on the hint. The address of the new mapping is returned as a result of the call. Okay, well, I guess the main reason to maybe use this okay, so basically if we're looking at the hint, which is kind of, I guess, interesting at this case. Well, in any case, like, the operating system will choose a location, and this is just a hint. Next hint. So where is this? Strong atomic compare and exchange. Expected value, new value. New hint. New hint. Result pointer. So we're just keeping the okay, so we take the resulting pointer and just use it as the next hint. It hurts to read about how malloc works. I actually read the C code of malloc once, and that is kind of like, it's very interesting because it does keep track of, like, I think it keeps track of like free memory areas that you can actually go and use. So it has some logic there for like reusing freed up memory in things that have been allocated before. And I thought that the arena allocator would also do that, but it doesn't. It's just a very simple allocator. But this one seems to be maybe what we want, perhaps. It depends. I mean, it depends on how this works. The map. pick a nearby boundary always above or always above or equal to the value specified. Above or equal, so only in one direction. The kernel will pick a nearby page boundary, but always above or equal to the value specified. If another mapping already exists there, the kernel picks a new address that may or may not depend on the hint. Okay, so you always get an address, and it might be close to where the last address was. The address of the new mapping is returned as a result of the call. Yeah. You can have this flag exec, and now you can have dynamic a dynamic program like exec and write, exec read and write. But I think that's a major security issue. Usually the execution part is only read. But you can, I guess. Maybe you can't actually. Maybe they... No, maybe. I don't know. One or more of the following. Yeah, because if you have it exec, that means it can, like, code, it can be executed there. So if you jump into there, then it's just executing there. And if it's you have write, that means you can write over the code to do something else. So you can have like a dynamic thing going on there. Map shared value. Okay. Shared is mapping. After this mapping are visible to other processes mapped in the same region or carried through an underlying file. Map shared validate. Flag surprise. Private. Copy and write mapping. Updates to the mapping are not visible to other processes mapping the same file and not carried through to underlying file. It is unspecified when the changes to the file are changes made to the file after a map call are visible in the mapped region. Anonymous. The mapping is not backed by any file. Its contents are initialized to 0. Okay. Argument is ignored. However, some implementations require FD. Oh, it initializes to 0. Interesting. If map analysis numberness is specified, portal application should ensure this. Offset argument should be 0. The use conjunction map shares possibly links. Okay, unmap deletes the mapping for the specified address range and causes further references addresses within the range to generate invalid memory references. The region is also automatically unmapped when the process is terminated. Good. On the other hand, closing the file script does not unmap the region. The address adder must be a multiple of the page size. All pages containing a part of the indicated range are unmapped, and subsequent references to these pages will regenerate. Okay. So if you want to free like one part of it, you can't use this, because that will free like everything in the page. So how does free work? free. It just does unmap. Okay. Right, but it depends on the size of the page, I guess. So do we decide the size of the page? Mappings, well, mappings employ huge pages, the requirements, or are they calling just a call to mmap like one page? Because in my mind, a page can be like an area of memory where it can have several things. But this just means that... Okay, maybe like... Okay, so alloc is like supposed to be for a new thing. Resize, realloc. Now we may be reusing the same page perhaps. And this is used sometimes by things. By like the standard library and stuff. I never use this. But like array lists, if you want to append stuff or yeah, do things like that. Alright, well this makes sense. The only thing here is performance then. If we use this allocator, we probably don't need too much implementation of the garbage collector. I'm saying that now, but that will probably come to bite me in the ass later. I mean, as long as you're freeing stuff, it's gonna get freed in this system and everything will work out, right? So, well, we don't have loops, so we can't really test it. Maybe that's the next step now, making loops. Also, I want to fix this. No, wait, that's not correct. This is the wrong thing. It's gonna be highlight. It's gonna be over here somewhere. Yeah, I'm saying embedded here. What does that actually mean? Yeah, you do that, Cephalus. Good night. See you later. Yeah, I'll, maybe I missed yesterday, so I might do 2 in a row here. We'll see. We'll see if I have the time. Have a good one. Embedded. What about, can you just do like expression or something? I'm not sure. Trying to fix Lexer. What's the issue? I'm Dr. Lexer. No. Let's. Okay, I'm gonna Google something real quick here. Tree sitter query or SEM expression. Okay. Yeah. So basically, I'm using tree sitter here, and what I want to know is how you just say that it's supposed to be any kind of expression, basically. Okay, so that's apparently not a thing, maybe? Predicate equal... What if we just remove this? Or is this a special kind of... Infinite loop. Alright, so you have to... injection language. Does that work? I mean, okay, new, that's 2 years ago, although I might not have it. Okay, let's try. Injection. Do we supply like a string here? Okay, can I please do something? Holy crap. Injection language. Injection content. Oh, I see. Injection language tries to like read the language from here, and then content is the thing in there. I see. Well, if I already know the language, I mean, there's probably a super easy way to do it. I just don't know. No, there's a library for this. String as HTML, JSX, and TS files. Oh, and TS files in your editor. Injection. Okay. Injection language. Okay. Wait. Set injection language. Injection content. Okay. Let's try this. Actually. I mean, okay. Here we go. Let's try this. The actual, like... Well, I'm not sure. Well, I don't know what include children is. But let's do... Oops. No, we actually don't need to do that. I mean, I wish there were just a way to say that, yeah, this is any kind of expression in Runic. Because it's not really an injection. It's like injection, but it's the same language. I wish you wouldn't do that. Maybe there's a setting in Vim or something. Also, why didn't it complain when I did this? There we go. But I don't think this works still. Or maybe it does. No, it doesn't, because this looks weird. I mean, maybe we could just look at the TypeScript thing. Like if we, let's say, we have a TypeScript and then we have a string and then we have like some text around and then we have this. Yeah, see, this is what I want. And then we can inspect the tree. Template substitution. Can we... config info. No. What can we do? Install info. No. Edit query user after. What is edit query? Argument required. Inherits ECMA. Okay, here we go, maybe. Highlights. Template. Punctuation special. What was it called? The template substitution. It's not in here. So let's look at ECMA, I guess. Injections. Template string injection const. Okay, here we go. Here's like a whole thing. Wait, but this is HTML SQL. Okay, this is like a template. This is like a, you're calling a function, giving it a template string. We want something else. Foo.sql? No. I see, they like do this. Glimmer? What the hell is that? Styled. Oh, that's cool. Angular injections. What? They have this in here? That doesn't seem right. What? That's it? Is it Angular 1 or Angular 2? Oh, sorry, Angular, like, I don't know, 50, whatever they have now. I used to work with Angular 1 for a while. Not 1 because templates. Okay. Right. You can see this one, yeah. The decorators. Directive scopes, yeah. It all comes back to me now. I don't want to think about it. I wished I worked in React instead, but they chose Angular. And then I went to work in another place, and we tried to make them use Angular for a new project, or I mean React for a new project, but they chose Angular too. Dropped lazy for Vim pack, built-in and plugin manager for 0.12 lightly. Oh, cool. I just roll my own config and everything. Double binding. Lost that fight. Yeah, I guess, yeah, React, actually, that's kind of interesting because React doesn't have that. So, but it still wins. Okay, so this doesn't work. Oh, here we go. Template substitution. No, that doesn't work at all. What is Glimmer? I never heard of it. So good, delete Angular files. Inherits ECMA. Well, this doesn't make sense to me. Template, like, okay, ECMA inherits ECMA, okay. TypeScript? No. JavaScript? No. I don't understand. Do you inherit anything? No. At none. What? God damn it. Oh, I need to, okay. I need to go here first. And then do that. And now we're back here. What if I say at none? No. Oh yeah, this does, okay. I mean, it kind of works. But it's the weird, like the colors are weird. This should be like white or this same color as this. I think the LSP gave up. Oh yeah, also here you can see we should really have like a new line terminator here. I wonder how this works. Got plus. Let's do that. Yeah. It's skipping over the new lines if you're in a string. I should really fix that. So tokenizer, that should be like an unexpected token or elixir. String interp and if we get a new line, we just do that. If the context is equal to string, we are gonna return unexpected token. New line in string not allowed. You're welcome. Wait, unexpected token. Expected string and got new line. Okay, it already... Oh, wait. It already did it. How? Where? Why? Current context is string. We do a text. Okay, so here we should look for new lines. If it's a new line, we break unterminated string. Okay, so we already kind of do this. Why do we get unexpected token then? Oh wait, I'm stupid. This now counts as a string and now we're out of the string, so now we're looking for interp end. I see. So what if we do this? Now we should get unterminated string. Yeah. There we go. Okay, you know what? Whatever. It seems like none. Like this seems to work as well as embedded. I wish it could like just be as simple as, I don't know, language content set language injection injection language to runic invalid capture name in injection language. Okay, maybe I have a too old version then. injection language indicate capture should have its concept reparsing another language. No, it shouldn't. Okay, so maybe none is supposed to work, but it doesn't because I don't know. Okay, anyway. That works. Where were we? Next up, I think if we go to do, we have string concatenation. Nice. But I'm actually contemplating whether to actually allow string concatenation or not. It's because in TypeScript and JavaScript, you end up with expressions like this. You know, 5 plus 10. What do you suppose this should be? What? Oh no, sorry. This is 510, right? You can imagine what kind of issues or, you know, mistakes you could end up with when doing this. Or even, you know, if you have some kind of string and you do like s plus 5 plus 3. What will this be? Wait, is it really? Is this gonna be 15? Are you sure? I think it's 105. Yeah. Unless I misunderstood you. And this one is 8. Okay. No, it's 53. So yeah. How do you reason about this? You don't. What you do is if you have this, you do this. So you don't ever reason about mixing strings with numbers unless the numbers are isolated or put into a variable beforehand or something like that. Or you can also use interpolation, which solves the whole issue. So you have s, and then you have, you know, 5 plus 3 or whatever, which it does basically, you know, the same thing, but now you don't get that issue. and it really eliminates the need to have string concatenation using plus. So I'm not even sure if I want to have it in the language, to be honest. We could allow it, but then maybe... Okay. One thing is, like, when you do string interpolation like this, things get automatically coerced into strings, right? In JavaScript, that happens with string concatenation as well, which is, I think, the mistake. But in, I think, for example, Lua and... Or I'm not sure about Lua actually, but Python, you will be able to... Actually, I should have Python here as well. You're able to say like S... Okay, I'm not too sure about the syntax. What the hell is this? pprint. Okay, I'll just test if this works here. Yes. Okay. Does this support concatenation? Can only concatenate string, not int. So what you have to do is make it into a string first. But that doesn't happen in JavaScript. That just allows any weird expression you have to be turned into a string automatically. And that's why you get all kinds of weird issues. Like this, for example. Except this is now string interpolation, so it makes sense. But it's also like it kind of like, okay, the implicit interpolation versus explicit. Also, like this implicitly does everything into a string, while here you have to be explicit on how the string is constructed, which I think is a good thing because it would eliminate things. But it's also, you know, in my language we actually have automatic coercion right now. Like if I say this is echo, and then, so if you run this now, there's nothing here. But actually there was like a new line for some reason, but not sure, does that always happen actually? Yeah, okay. So it does, it's not depending on this on these things. But you can echo now E. Okay, but what is E? E is assigned to a pipeline. And what happens is when we get to this line, the pipeline gets executed and the result is stored in E. But what is stored in E? There's like, each pipeline has like multiple things in it. So you don't only get standard out here, like in, I think a bash does that. You get the whole shebang here. You get like standard out, standard error, the exit code, anything else you can think of. You know, you get a process handle here is what it's called. And we interpolate this here. But what does it output? It outputs the standard out part. So when we run this, it just says the thing, standard out here. But we could also call, or we can also access standard error, which is nothing. Or we can access standard out, which is also like hello world with a new line there. Was that happening here as well? Yeah, we get 2 new lines. And then there's exit code, but we don't support that yet. So we don't have, you can't actually get that right now, but yeah. So this is like, this type here is not a string, it's a process handle, and it gets automatically coerced into standard out, which I think makes sense, and it is, you know, a kind of, so automatic like string coercion when using interpolation kind of makes sense. But then you also have the option of converting it in the way you like as well. So yeah, because otherwise you would have to like type standard out every time, which I mean, I don't know. I actually, this is, I'm kind of on the fence with this one. Because then it would also imply that you cannot actually interpolate things like strings, for example, which you can now. Now there's a new line here because of standard out has like a new line from echo, so that's why you see a new line here, because it doesn't look like this expression here, but it is. Oh yeah. Maybe we should do like more string manipulation, like slices. Yeah. I'm gonna write that down actually. Oops. Strings. Yeah, I think string concatenation. It just opens up for mistakes to be made. And it also, another bad thing about it is that we have more things, like you can make strings in more ways than one, I guess, which also is better if it's simpler and less complicated, and you could do things in the least amount of ways, I guess. Maybe not really like that, but for this one I think it makes sense to not have it. Maybe bad. Just because of the fact that you can make a lot of mistakes with it. Because if you want to do this with explicit, every number expression we also have to like wrap in some kind of string converter, which also this string converter is like, it's I think it has like a default implementation, like in the case of Python, for example, for every type. I don't know actually, but it makes sense. Like you can put something in here and it puts out a string, you know. So how does it deal with, you know, arrays, for example? I actually don't know. Oh, it just does that. So there could be like, you know, I actually like type classes, but I'm not sure if we're gonna be able to make type classes in Runic. That would be insanely hard, probably, but really cool. But maybe we'll have something simpler. Maybe, I don't know. Maybe there's a nice convention. Yeah, I mean, I think there's probably in Python like you can. I distinctly remember there is some kind of toString or some kind of function that you can define that will be called if it exists. I think there's something like that when you make like a new class or something. How do you make a Is it 2-string or 2-string like this? Maybe it's something else. Maybe it does. Maybe it doesn't work. Okay. There we go. I looked it up. Yeah, this is similar to like JavaScript also has. No. So like you have a class, or you can even have, you know, just an object that has like, yeah, just value is the value, and then you have like toString, and O is O. Yeah, that's the same thing. So this kind of makes sense, and I like being able to do this kind of thing. I'm just not sure exactly how it will look in Runic, but yeah, it is something that you could think about. I just know right now that we probably want to ban like plus string, and just use interpolation, because that properly kind of isolates the expressions, and you don't get confused on, you know, number plus number. Like, I don't mind implicit string coercion, but I do mind when numeric operations gets mixed up in string operations. So I think I'll go with kind of like a mix, so you can do this, so you don't have to explicitly convert to a string, but you can't do string concatenation with plus. Everything should be coerced from string instead of the other way. Everything could be coerced from string instead of other way, like JS. Could force user to implement a formatter or compiler. Right, that could be a thing. That could be a thing. Like, yeah. So yeah, I mean, you also saw like Python and JavaScript actually did the same thing. It just printed like a default representation of the value. If it in Python, it showed a little bit information about the class or the type and stuff. And then JavaScript also showed like, yeah, this is an object. But since there's no string handler, we're just gonna show the default thing. And in my language, to me, that feels like, okay, well, it's easy to just, if you want that, but I think more often than not, those kind of string coercions are like, we never use that. Like, if you see object, you probably have something wrong with your code. You're not meant to like, and it's not useful. I've never seen that as useful. Maybe it's useful in some certain situations, but you know, in my professional 10 years of experience, we've never had like, that doesn't like, it's better in that case if it fails and it tells you that, hey, this doesn't have a like an explicit string handler or something like that. So yeah, I think that's a good idea, to force the implementation, and that could even be like semantically analyzed, so you don't even have to worry about it in runtime. Because in Runic, if you have a string variable, it's not going to be able to be reinitialized or reassigned to a number or something like that. We don't have dynamic variables or dynamic types. There's static types, and that's just fine and dandy. Yeah, so that's how it's gonna be. Case closed. And I do realize that it kind of goes against maybe, you know, scripting languages. Oftentimes scripting languages is dynamic for some reason. I don't think there's like a showstopper or anything that could make a scripting language. I mean, the only thing I can think of is like when you want to have dynamic imports. I think we could allow for dynamic imports if the name of the import is known at compile time. Then we could have dynamic imports, because then we can statically analyze all the types and everything. We don't have to deal with dynamic types and unknown types and stuff. Maybe once you have like a semantic analyzer, you could potentially like extend to have dynamic imports, and then fail at import time. And because I was thinking like, okay, let's say you have like a string here, which is like something, I don't know, unknown, or maybe even a function. Let's say you have a function that's you know, get module name, and then we have like an input string, or yes, some kind of path or string. We put out the string, and this does something. It like returns in plus, or you know, in slash index.module or something, I don't know, or .rm, something like this. And this is now it depends on runtime basically, because you can call this. So let's say we import now, module equals import, and then we do get module name, and the input is like, I don't know, my module or my library. Now this is a dynamic import, so what would be the type of this? Like, it would have to be analyzed in runtime. So basically the type of this is kind of like a lazy type. You could make it like a lazy type, so you don't know what type it is. You know that it's some kind of module, but you don't know anything more than that. So if we could allow types to be kind of lazy and evaluated, you know, over time, which could be a thing, you know, when actually analyzing, like doing a semantic analysis, you might want to have that anyway, because that that will simplify, well, or that would make it so enable you to kind of have types that are not evaluated yet. If let's say you can have like a recursive definition or something like that. That could maybe work. I'm not sure, but here this could potentially be some kind of lazy type, so module, but the subtype is not known. And then when we try to use it, like we say like module dot whatever lib function, then this wouldn't like fail directly because we don't know, like we don't know if we have a lib function or not. But then later, like in runtime, this gets evaluated. Now we know what the import is, so now we can parse the import and fill in the types here, and then check if we actually have this function when we actually get to executing it. So this would happen like in execution time. So in execution time, we would be able to like parse the script. You could do something like that as well, and that would maybe be the way we can do it, because honestly it's a script, so it makes sense to do it like this anyway, because things get parsed and executed at the same time. It's not like we compile this to a program and then execute it with just a runtime. We parse the file and execute it directly. So it makes sense to kind of do it like this. And we don't even need to store the type, to be honest, because the types are kind of, well, we don't really have semantic analysis right now, so there's no type checking step. There's no semantic analysis step right now. It only happens in like execution. Like for example, you can't have a string plus another string plus a number. So this happens in execution. Oops. Wait, failed to parse. Oh. Let's remove this. Leaked memory. Okay. There's an issue with leaking memory when there's an error, I guess. But yeah, this is an unsupported binary expression. So yeah. Okay, well, anyway, let's see what we can do now. So maybe, should we go for loops? That seems a little bit ambitious, maybe. Expressions. Everything is just going to be expression. I'm probably going to convert all statements to expression at some point. I'm going to keep the state, because right now we have like statements. We have, we have like a couple of statements, but I never create new statements. I always do like expressions now, because yeah, I just think that's the correct way to go. You should be able to use loops as expressions as well, and they will kind of, it's kind of like a fold in functional programming. Like you iterate and then you produce a value at the end. So, or you could just discard the value as well if you want, but they should be expressions. So loops. Have you thought of trying Advent of Code in Runic? I mean, I have to implement some features first. Like, we don't have loops. Wait a minute. Can we do recursion? But we don't have control structures. We don't have ifs. We need to have ifs at least before we can do that. I mean, it's either ifs or pipeline or pipeline and. If we can have pipeline or, you can call a function and then call or, it would actually check the exit code. You know, that you can have an escape route. Or I guess you can just trigger an error in the function. But I think maybe we can do recursiveness. Yeah. Because the function scope should be able to access the outside scope, which should have the function defined in it. Or is it a closure? Actually, no, maybe not. No. Yeah, the closure doesn't have the function itself. Maybe we should add the function into the closure then. I'll just add this here, recursive functions. Add function to closure. Okay. It would be cool if I could try to make it. Yeah, we definitely need like ifs. It would be nice to have loops as well to be for some of these problems. And or it's gonna be either loops or recursive functions, and then ifs. That's gonna be the way to go. Pipeline or is kind of like an if as well, like pipeline and pipeline or. Because technically we could call a function, use pipeline or if it fails. The problem is like we don't have a mechanism to fail a function. We don't have the exit / return statement. Like we don't have this. Exit is like, actually, how would you do this? Like, how would you want to return, but you also want to exit? Maybe. No, you could stand it out with something else. I guess with echo or printf or something. Yeah, if you want to do a string, return will be the value, but then exit is the exit code. I mean, I guess you could potentially return a value. No, you don't. Well, I mean, a normal function, like a function that has a string, could potentially have a return value, which is a string, but then also an exit code that is non-zero. Because the functions in this is kind of like processes in, you know, they have like, you can put things in standard out or standard error and take things in standard in, but then you also have like an exit code. Sorry, I didn't notice the raid there. Thank you, Robotic Head. And also thank you for the follow, Borochek. Wow, Penguin Operator reached a 5-stream streak. Awesome. If, loops, or, and, recursive. I guess if we do these two, which we probably should have anyway, we could start to do advent of code maybe. That would be kind of cool actually. Okay, should we just start on ifs then? We're just starting on ifs. Do we even have like a keyword for that? Yes. All right. If we do have an if, we already have a parser. What? Okay, so how does this work? We have if left parenthesis. I think we're gonna do like a maybe on that one actually. I think we're gonna do like an expression. Yeah. Okay. So we need an expression. This is gonna be, you know, the condition, yeah. The capture, I'm gonna ignore this. Well, I guess it's an optional. Yeah. And then we have the block. Yeah, I mean, I guess we have it. We have an else, maybe. If it's an else, we will... Okay, I guess we don't have like elif or else if like together. It has to be else if, which to me works really well. I don't like it when it's like multiple different ways to do it. It just doesn't make sense to me. And this makes way more sense in a definition sense, like in, you know, the parser and everything. So like you have the else. We do after else could be an if. If it's an if, we do an if expression, right? And that is now recursive. If we didn't have an if, we just have an else block. Okay, I guess we have the parser already. So, whoops. So what if we say like, if true, echo, yes, it's true, else, echo, no, it's not true. Right, unsupported expression. So it does, we do get an AST. All right. Cool. So let's go to the execute or evaluator then. Now, for now, I'm just gonna say that the expression will evaluate to a void. No. You know what? What is the expression? Actually, it's an if expression, okay? Yeah, it is an expression. Okay, good. So, let's get the condition. Now the condition has to be a bool, otherwise it's like a type error. Now, where else do we have like a type? We have a type mismatch, I think. That's here. Script context. I want to have kind of like type mismatch error or expect type, and then we get like a value, and then we need the type. So I guess we will get like the value tag or something, and this would be like an error, or I guess we could just return the value if we're successful. So we would just check like if value is equal to tag, return value, otherwise return type mismatch. And then we could have some extra information here, like we're logging log, no, trace, no, executor, no, I don't know, let's do log error type mismatch error expected this, actual this. I'm contemplating whether to put quotes around it, but this is like type name of, no, tag name of active tag value, expected is tag. Let's just call this like expected. So expect type boolean. Okay, and then we can actually just grab the condition value. Now this should be like a bool. And then we could actually make expect bool. What do you prefer, boolean or bool? And this would return a bool. Yeah, and here we just say like return try expect value, expect type, I mean value expected is, well, we know what it is, it's a boolean, and then we get like, oh yeah, we do this, that's right, boolean dot boolean. There we go. So now we can just say expect boolean instead. We don't need to do any of that. There we go. All right. A little bit of nice helpers is always nice to have. Okay, so then basically, like if condition, we execute the if expression, but that's a block. I guess, okay, well, technically, like how blocks work here is like the value is gonna be the last expression, but that feels so magical to me. I don't actually like that, like the implicit return of the last statement of the thing. Like that doesn't sit right with me. I'm just gonna return void here, and that's that. But we're gonna have some way of making a value out of the if. Like let's say you don't have a block, let's say you just have an expression, then it's easy to just pick that expression as the value. Like if you don't have curly if you don't have brackets or braces, or yeah, braces, then it should just be the expression that you have there. If you have braces, in Zig you would do something like have a label and you break true here, for example, or I mean any kind of expression, and that's the result of the if expression. But I'm not sure if we're gonna have that though. Maybe, since we are making like a zig-like bash script language here. But yeah, anyway, if condition is true, this is a bool, so it's already evaluated and everything, then we will say if expression then block, we will try self evaluate block expression and we get a value, but I don't want to use it because this is like, yeah, it's like a block result take. This one is like the last value. I don't really like that. I'm just gonna do this and then return void at the end. Else we just try evaluate block expression on the then block. No, I mean the else block. If we have one, so if we have an else branch, we execute that. Actually, wait. Oh, this is a union E now. Okay. I think, yeah. So we have to do like a switch on the else branch. If it's an if, I will do like else if expression. Then we would just evaluate that if expression now recursively. There we go. And in that case, we could actually just return that. But no, let's not do it that right now. Or we have an else, which is just an else expression. And now, whoops, we do evaluate block. Else expression, which should be a block at this point. Why is this not working out? Is it this part? No. I'm pretty sure you can do that. L switch. Is it because this is called else? Okay, it's because this is like a keyword. Oh, I see, it's just block. Okay, fine. Expected 1, found 2. Oh, yeah. Value of type, value ignored. Yeah. same thing here. We just throw away that. What is this? Oh, you need to be... Wait, you're a pointer. You want a non-pointer. It barely fits here. Nice. Okay, so now we have the basic like if-else there. Expected e-number unit type. Oh. There we go. All right. Let's see how this works now. Well, let's go to test RM. And let's run Runic. And we get a bunch of leaks. And nothing happens, so great. Okay, where are these leaks? Well, the leaks might happen because there's some kind of error or something. Oh, wait. I know what why there's leaks. Because the values we need to deinitialize those. So we get like result here, and we just deinitialize that result. There we go. Now we shouldn't get any leaks, or we do. Did I forget something? Oh, we need to deinitialize. Oh yeah, we need to deinitialize this as well. The value here. Maybe. So condition value. We're back from a 4-hour-long exam. Damn. Condition value, condition value, initialize. Yeah, because a boolean shouldn't even have memory, so what is actually being... $839. What? There's something weird going on with the... No, evaluator 839 is over here. It's like between functions. And then we have like script executor 201. Standard out is being not cleaned up. Okay, so let's say we run this if expression, which we are doing. We get a block, we execute the block. Yo, Penguin. Are you talking like, what language is that? Is it German or... Are you doing number 3 code challenge today? Yeah, I was thinking someone challenged me to, like, Vicent, you challenged me to do Advent of Code in Runic, but I have to implement the if statements first. I'm probably gonna do number 2 and 3 today if I can make it. I have like a couple of hours left. Maybe I should start. Okay, we'll try to do if statements, and then I'll do 2 and 3. However, I will do it in Zig. Wait, that wasn't even... Oh, it didn't even compile. Okay, well, interesting. So it actually does work. I see what's going on. Okay, so basically, okay, what? So this is a bit technical now. Basically, this gets executed as a block, but the value is kind of like normally, like if we the only other block we have is a function. So if we call the function, that will show the thing. And that's because this gets executed as a block. However, it's executed in kind of like a function context and its own executor. And all the standard out that's happening in this block is like captured in for the executor, and then it's forwarded to the outer context from where it's called. So we're calling it here, which means this gets executed with its own kind of executor and with its own like context with the standard out and standard er. And then when we kind of get back the value from here, and then the outer this all the statements are like, or yeah, when we get here and the statement is done, the value is passed out to the executor and the executor will forward it to its context of standard out, standard er. And in the outermost context, that's just a normal process standard in, standard er, right? So when we call this function here, this will get forwarded to standard out, standard er. However, when you execute a block, it doesn't get forwarded yet. So that's what's happening here. Like we execute this block, but the standard out is not like captured and forwarded to the outer context. So it wasn't as simple as I first thought here. Because of the whole like the standard out, standard er thing, it kind of complicates the whole language, to be honest. But it also is the thing that you want to have in this language. So we need to have it and we need to handle it. If you can do it in Zig, that's already fine. Okay, cool. Thank you. Yeah, I will not do it in any other language. Maybe Haskell. No, not Haskell. So I think maybe we need to like do every block in a new executor context, and then then that context will be like forwarded out. Or, well, yeah, because we have to capture the whole thing. We have to capture the entire block execution. Yeah, so this is probably gonna be its own like you know, pseudo kind of process handle thing. It's like every time we want to do a block, we need to put it in a context, execute it. All right, let's see if we can do that. So technically now we are evaluating these things. It's just that the result is not used really. Like I could show you here, like if we actually use the value, we instead of deinitializing, we return it. Right? Now we return it. Now it should actually be like we should get the standard out now, because because the reason is that this is the last statement in the expression in the block So this would get passed out as the value, and then the result of this entire expression is a process handle, which then will get like evaluated just as this one here. So now we should see, yes, it's true. Okay. But yeah, okay, so do we want to do this now, or do we just declare this complete? Because the thing is, like, you can have this this will not get echoed here, and that's just to prove the point here. That's not gets echoed, it's just the last one that gets echoed. So what we need is this whole thing to be in its own kind of world context thing, and we pass it out as a process handle basically, which then will get forwarded to standard out. Just like a function. It's just like a function body gets executed, which we already have a way to run. So maybe we'll try to just reuse that. Evaluate a block expression, like this should always become like some kind of process handle. Yeah, I think we'll keep this code. This should work. Not sure how we get over here. It's like, I guess if you only have an if that doesn't do anything, then we get a void. Maybe. Yeah. However, this block expression, right, we just take the last value, so we get a block result, and you only keep track of the last value. Okay. I mean, that's for the result, like the return value. What I was thinking is we cannot call this directly. We would have to call this from another function that is the, like if we do run function, for example, this one is getting called when we want to run a function. It creates its own executor and its own scope and everything, and owns like standard out, standard. We execute the block here from this function. So we basically want to do something like this, except it's for just a random code block in the code that might have it more scopes or something like that. So we should probably, I'm just gonna make a copy of this. Also, we have like run function as pipeline. That could be cool as well. Like if you have a block of code and then you can potentially just pipe that into something else. Okay, but let's do one thing at a time. Let's just copy this. Do like run block as in own context or something. And we need a block here. Let's just wait. No, this is a AST block, which will be, yeah, sure, whatever. And we don't need to grab another document because we already have the document. I guess we are using our own executor. Yeah, why not? I think what we want to do, yeah, we have execute options where we pass in standard out, standard error. Yeah, so we don't need to create a new executor. I think the only thing that's kind of weird is the scopes. But we don't actually need, like, because we're passing in the scopes that we have currently anyway. So we actually don't need to do this, any of this. We do want to push a frame though. Actually, we don't need this. No, hang on. No, we do. Okay, we do that. Oh wait, how do we get the executor? No, we just get the current document. That's right. Okay, we don't have a way. We don't actually have. Do we have like path? Yes, we do. So I'm just gonna make a function called like get current document. Path is gonna be, well, we already have path. There we go. Get current documents, because now we can get the executor. If we try this first. Script executor. And if we don't have an executor, which we have to like, this is gonna be an error. Alright, and then we set up all this crap. Why is it a const? If there we go. Okay. So we have the executor. Then we execute. The statements are gonna be block statements. The span is, I guess, block span. Wait, this is the block. No, it's the script. Right. It's basically the same thing as it has the exact same thing as the block. So maybe this should be just be a block. It's exactly the same. Okay. Anyway. Then we have a path. That's the same path. Standard out, standard error, context undefined. We pop the frame. We gather the result. And that's... Excuse me. That's what we're doing. Alright, so now we have a way to run the block in its own context. Hopefully this works. Now let's go back to if expression. So the blocks here, we can't just evaluate them directly. What we need to do... okay, wait. We're missing we're missing a thing. Run block there. So when this result is when this function is run, this is happening over here. No. Where is this happening? Over here? Yeah. We're taking the results and we're doing this is some weird like gymnastics here. But basically we get this result out. The result is then put in these things and we produce a process handle. So basically I want a function that just takes the result from a function. So basically I'm gonna copy this. I'm going to go to evaluator, I think, and put this here. Now this will be like run function result to process handle. And we get the result. And what we get is a stage execution, okay? Yeah, because this is like part of a pipeline. I mean, this is probably almost exactly the same as a process handle. Okay, runs this executes this, run stage is being, so the result is grabbed here and we capture it there, and then we get a process handle with the stages. So we basically want to create a process handle with the stage. So this is the stage. Stage. Wait. Where is it? Oh, it's not public. Okay, we'll make it public. Stage execution. And then we return the process handle. Which is then just returned. process status. That is just stage status, okay. So this would just be one item of stage status. Okay. And then we have stage captures. Which should just be like standard out. Okay, what else? I don't think we have much else there. So now we can talk about this process handle. Now this is like fully integrated in the thing. Yeah, script equals block. Yeah, that works actually. Const script equals block. That does work. You can use them interchangeably. Let me delete this. All right. Cool. So instead of running the function, wait, yeah, we don't run the function. We get the run function result that we already have. Let's just get rid of this. Oops. Args. What? Args index function. Wait. Wait, we don't need to do this. There we go. What is this? From term status. Oh yeah, from terminate. Okay, from termination. We don't really have a way to embed it here. We should probably add exit code here, but yeah, and here we kind of simulate an exit code. And I'm just gonna say that it's a success right now. All right. So really this is like a, it's not really a function, but whatever. Also, what is this used for here? Index. It's not used for the function. Oh, it's just passed through index. Oh, it's which stage it is. Okay, okay, okay. Wait, is it? Why is it args.index? I think it's with, I think it's the stage. Okay, well, anyway. Now this is done. Use of undeclared primary ID. Well, we don't really have a primary ID for this, so I'm gonna say that this is a function. Well, it's not really a function, it's more, it's actually like a block, but I will just say it's a function. Started at, I mean, we could do started at, oh, we already have. Actually, then we need to have this in here. Yeah. Yeah, okay. Let's just put this in here. It's not super important, I guess. Wait, no. Started at is a all right. What is this? The stage. Okay, we got past the compiler errors. But this is not called, so there might be more. Okay. Also, this is not called. Wait, run block. Yeah. We need like started at and this here as well. There we go. Okay. Are you called? No, we're not calling that. So evaluate, well, if expression. Back here. Now this one, we will do like try run block in own context, which will return a run function result, but we should what we should do is we get the result here. This is the run function result. And then we return self run function result to process handle. I mean, we could just do this as well. Okay, so now the result of this is going to be actually not a run function result, it's going to be a process handle, which is the type that we want. So scopes block, whoops, is if expression then block. Okay, let's just try if this works. Okay, we got some errors. Expected this, found that. Oh yeah, we need to do this to get the actual pointer there. Then we have switch on this. Run function result. Oh, we'll just remove this and say results directly there. There we go. Expected type found that. Okay, well, can we pass it like this? Does this work? No. So you have to do like I mean, or we could pass it in directly here because it will get chorused. It's just that we have to do it multiple times. Whatever. State status. I think this will work. I guess we'll find out. No. What about this? No, that doesn't work. Okay. So we have to specify command runner, or there might be another way to do it. Stage capture. Okay, and now here we need to put an ampersand on all of those. There we go. Or not. What the? Okay, let's do this then. God damn it. What the hell? Okay, let's see if we can find try this one. So this is a process handle. So actually, well, you know what? Let's return a value instead. There we go. Okay. This is still an issue. What? How? Yeah. It's like the compiler's like, yeah, just put a ampersand. No. Fooled you. Now we get this error. So what if we do this? No. It's a slice. It's a slice with a known. No, it's an array. It says it's an array. Okay, what if we do this then? Will this work? No, that one's gonna complain. No, it's still okay, but now what if we do this? Man, I'm going crazy with this. I didn't think this was that hard to do. Actually, you know what? This is good that this is an error here, because I just realized that we're returning this. Yep. So we can't use the address here. It's very, very good that we get an error here, because I just realized that, well, I'm trying to do something that is kind of impossible. Also, when, yeah, this destroys the captures. Okay, so yeah, okay, so let's just allocate, I guess. Self allocator. We could do like a dupe maybe. Stage status. Yeah, this should work. Yeah. Okay, there we go. It was just me, not... It was me being stupid. Okay. Now, we don't have any more compile errors. And if we go back to the evaluator and we go to if expression, you can see here that we're running this. This is like we're running this if the condition is true. So if this is true, then we run this. We get the process. We run the block in the executor, but we're also creating like a new standard out standard like scope, execution scope here, and then we execute these block statements here. This doesn't matter that much. Standard out standard is set here to this kind of in-memory thing, and then that's executing that. And what are we getting here actually? We get an exit code which we don't use. We could potentially put the exit code in here, but whatever. Okay, and then we convert this result into a process handle, which we then convert into a value, which we then return here, and that's it. And then that gets forwarded to the outermost context and properly handled now. So if we go back to the test file, and we see that before this will not get echoed, but now it will get echoed. There you go. This will get echoed. However, the else, we didn't do the same treatment to the else branch, so this will not get echoed. If we do false here, we only see the last value because that's what's getting like passed to the thing there. Now I wonder why we don't see this twice. Is it because it gets like deinitialized or something? Because yeah, the last value, I'm actually gonna go back to not returning the last value. No, because okay, yeah, I see. This whole thing is now no, because the last value is this process handle here. No, we never returned the last value. That's right. That's right. We just what are we doing? Actually, yeah, this handles like deinitializing that. Right. So the value gets disappeared basically in here. Okay. But instead of doing this now, we do run block in on context. And there we go. That should be that. We'll go back to test now. Now this should get echoed here. And there we go. Awesome. Hello, Nutslider. Do you read any books or articles prior to creating this language? I mean, I read like, well, not books, maybe. Like, that was a long time ago I read books. Like, I read, like, you know, basic programming books a long time ago. But articles, I've read, like, some articles here and there throughout the years. Like, you know, I mean, I probably read a bunch of stuff on parsing, maybe. I don't know. I never did like a proper deep dive into it, but I've tried. I've basically, the thing that sparked the interest of parsing to me was when I tried the Parsic, PARSIC library for Haskell, which used kind of like a combinatoric sort of way to parse source code or parse text or whatever. And it just clicked for me. Like, I just, wow, this is incredible, I thought. And I just learned how that worked basically, and then I just tried to copy that in a bunch of different languages, like copy that kind of library over the years. But I never done anything like this, like to this extent that I'm doing here. Okay, cool. So now we can even do this. We can do this, I think. And then we can echo the result. And there we go. It just works. That's really cool. That's actually really good. Okay, so we have if statements. Good. Now let's do let's do this if we have time here. I'm gonna check something here. Okay, I have about an hour. So let's see if we can make this here. Runic is the final name for language. I don't know actually, but I just tried to pick something that was, I think I googled it and it was free. Maybe. I mean, I'm trying to like search for runic lang, and you get like a bunch of rune, like, you know, the runic alphabet and stuff. Okay, let's do the... Oh, Sunpoke 04, thank you for the follow. Wait, did I already say that? Maybe. I don't remember. Sorry. Where is my advent of code at? Here we are. All right. 2 stars. Where is the thing? Okay, this one is done. Look how nice it is. It's like an igloo or something, and an underground base. I guess this might be like the North Pole with the elves and stuff. Okay. Gift shop. You get inside and take the elevator to its only other shop, the gift shop. Thank you for visiting the North Pole. Gleeful explains a nearby sign. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here, and from there you can access the rest of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Typical. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product IDs ranges already. They only have a few product ID ranges your puzzle input that you'll need to check. For example, okay, so we have a bunch of ranges here. ID ranges are wrapped here for legibility. In your input, they appear in a single long line. Great, so I won't be able to open it in NeoVim then, because it will crash, I think. The ranges are separated by commas. Each range gives its first ID and last ID separated by dash. Oh. Okay, so it's a comma separated, and then each comma has like a hyphen separated. Okay. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. So 55, 5 twice, 64, 64, 64 twice. Would all be invalid IDs. Interesting. None of them numbers of leading 0. 0, 0 isn't an ID at all. Okay, so we have a bunch of rules here. 101 is a valid ID that you would ignore. Why? Or we just ignore the valid IDs altogether, I guess. Your job is to find all the invalid IDs that appear in the given ranges. Okay. So 2 invalid IDs. And this one has 199. Oh, I see. We have to check every ID in here, in the range. Oh. Oh, I see, I see. Now it makes sense also, like in a database kind of way as well, like you would know kind of, or I don't know. But yeah, it makes sense now. Okay. Adding up all invalid IDs and expenses produces, holy moly, that's a lot of IDs. What is that? That's like millions. 1 billion. 1 billion row challenge. What do you get if you add up all of the invalid IDs? Get your puzzle inputs. Wait, that wasn't too long. Okay. I guess I could open it in Vim. Okay, let's do main. I have to remember the syntax now from this one. And I will have can you get the thing to input? Yeah, that wasn't too bad. Hey, look, I sold it in Runic as well. If you see here. Okay. Yeah, we'll read the number 2 here. And we'll make a function. What? Okay. Now, what was the rules? U size? Yeah, that should be enough, I think. It depends, I guess. It would be cool if they had a puzzle that required you to use like U128 or something. Unused function parameter. Yeah. So now we can start working on. So let's say the rules here. So the rules was that numbers cannot be repeated. 2 2 1 1 64 64 1 2 3 1 2 3. No leading 0. What else was there? Okay, so we have like ranges done in comma separated list. There we go. Go through each ID in the range. So 11 to 12 will be 11 and 12. Or 13 will include those. I think. Wait. Is that correct? Or is it in between? No, it is inclusive. It's inclusive. Inclusive. Okay. What else? Add up all invalid IDs. Okay. So let's make a range iterator. Of commas. And while we get this, we get a range. And then we just get, I mean, we could just very easily get it out, but basically it's nice to use the iterators. This would be like I don't know, ID iterator maybe. No, well, sure, why, let's confuse a little bit, and this would be like range. Why do I get these now? This shouldn't happen. Why do I get the stupid text here? Okay, anyway. Well, we don't do while, we just do... so we have the first ID is this next, and then we have second... second ID next, some errors. Okay, so now we get the two IDs. Let's I guess we'll convert it to integers, I guess. First, no, let's call this like ID string. Do you like my mix-up with different errors? Oh, nice borrow check. What was the issue? Okay, first ID is format parse int. Usize buffer is this, base is 10, second ID, all right, now we have this, now we have those, and then now we need to basically just loop through first ID to second ID to get the ID, and then we just say if is invalid ID. Well, actually, you know what? Maybe it's easier. Let's make a token. And we have the integer value from, let's see, first ID is gonna be token from Lexine first ID S, tokens from Lexine second ID S. Okay, now we can loop through the int to the second int. We have to try. And we get the ID here. And then we just have a function is valid. And let's return false just to check this. Okay, and then we just say if is valid. No, wait. Oh no, this doesn't work. No, this was stupid. This was stupid. I need to, yeah, I need to work with numbers anyway, I think. Yeah, because okay, the idea that I had was basically that I could maybe easier to check the string for repetition, but instead of the numbers. But let's just go back. Yeah, ID if is invalid ID, then we would, so we need invalid IDs equals 0, and then at the end we return those. If we have an invalid ID, we are going to increase this by 1. So now we just need to make this function here. ID is a usize, and we have a bool. Let's just try to run this by just saying true, or yeah, just true, and see if it works, or if we get like overflow issues and stuff. Yeah. Also, is parse int really? This should really be an error. Yeah. So we have to do this. Expected void. Oh. You have to have a thing there. Okay, parse int, expected type found. Oh, wait. Or else return error. There we go. Expected tuple or struct argument. Right. Okay, are we done with the teething problems here? Invalid character. Char to int. Let's check. Let's do like trimmed range. Yeah, thank you, AN. trim. If the length is 0, we continue. Okay. So there was some kind of weird error there. 1956042. So that's how many IDs that were like that was way lower than their example. Okay. I thought we were gonna get like a lot more. But we don't get like overflow errors or anything like that. Great. Okay, now we just need to determine what is an invalid ID. So let's bring the rows over here. I think these are the only 2 rows. So the whole ID cannot consist of repetitions and no leading 0. Well, no leading 0 is pretty simple. We can just... Oh shit. Okay, I see what's going on here. We need to convert this into a string before. Actually, you know what? Wait, what does that mean? Like, what if you have a range that looks like 0, 10 to 100? Like, would it count 0, 11, 0, 12, 0, 13? None of the numbers have leading zeros. Okay, so we don't care about leading zeros. Okay, that I think that's maybe that's just a clarification, maybe. Okay, so we don't care. Okay, we don't care about the leading 0 thing. It's just a clarification, I think. So you don't like go, oh, what if there's like this edge case and that case? Yeah. Okay, they cannot have repetitions. So what I'm thinking is we create like a repetition buffer. Which is an array list of U8s. And should we have like a max, or do we get like, we just get the, let's just get like the page allocator. I think you can assume no leading zeros will appear. Yeah. Thank you. Yeah, exactly. That's what I was thinking. Allocator. What is happening here? Oh yeah, sorry. There we go. Okay. So yeah, so the idea is that we would fill up this buffer like one by one. We don't. I mean, we don't really need a buffer, to be honest. No, we don't need a. We don't need this. We just need a number. We just need like a repetition length, and we start at 1, of course. So the idea is now it's 1, and we're gonna check. Okay, what's the first one? It's now that's the repetition sort of slice. And I guess we will check. We don't even need to store that. We just need to do max length. We need to have like some sort of max length. is gonna be like ID mod, what is it, ID divided by, no wait, what is it, is it log 10? That would give us how many digits are in there. Does this work for integers? Log 10 int returns log base 10 of the integer value x rounding down to rounding down. Okay, yeah, so that should give us the number of digits, I think. So we'll do from 1 to max length. Do we need to do like +1? Ten to the x is 10 to, wait, 1, 10 to 0 is 1. So we should, this should be +1, I think. Okay, we get, you know, repetition length. Is usize the automatic minimal size of the integer? No. Usize is like an unsigned, U stands for unsigned, and size is kind of this, is kind of, it depends on the operating or the architecture. So if it's a 32-bit system, it's 32-bit, 64, it's 64-bit, I think. Don't quote me on that, but I think that's how it works. It depends on, but you know, normally you have like, you can do U64, you can do so these are kind of the normal types. But then you also have usize, which is used for iterators. So I guess it's because maybe because of how the kind of assembly works when you want to iterate. We're using like, I don't know, the or CX or whatever for the loop thing. So I think it's because of the, or like, depends on the architecture and it's used for iterators. Like this example here, this is always a usize. If you have a 4 with a range, the type of this element is always a usize. So that's why it's convenient to use usize here for ID. Maybe in this case we don't really need to have it usize. We could probably get away with like U64 or something, but I think U32 is probably enough to solve the problem. Okay, so we're gonna have like the repetition slice is gonna be let's just convert this to a string. We convert it to a string. We free it later. We could technically pass in. No, we don't. We can't. We have to convert it. Okay, because it's easier to work with now, I think. We get like the rep slice. Well, I guess we'll find out if it's easier to work with or not. But my idea was that we get the rep slice is going to go from 0 to repetition length. So we start at 1, right? So the first iteration, we're going to be at the first number. So now we check, okay, is this pattern going to repeat? So now we do a nested loop where we go from, we start at rep length and go to ids.length, and then we will get I here, and we will have to check. We can just use equals, and we're gonna do, okay, so if rep slice is equal to the, so let's grab out the compare slice, which is gonna be IDS, and then this is gonna be I to I plus rep length. Now I needs to be increased by rep length minus 1 as well. If this is not true, we will have to break from this loop and continue. No, wait. If this is not true, we just return. No, wait, hang on. No, if it's not true, we'll try the next one. Yeah. There's probably some efficiency you can do here, like if you have a number that looks like this, 2, 2, 2, 2, 2, and then a 4. So this algorithm would check like first this one, okay, that error. Then we check this slice, so we check the here, yeah, that works here, the other works here. No, it doesn't work, okay. Then we check this slice, this works, this doesn't work, okay. Then we check this slice, this doesn't work, this doesn't work. And then we're done actually, because the max length should actually be like over 2, I just realized. Div floor. Is it floor? You can't split the string in the middle to compare the halves? Yes, you can. Welcome back, Penguin. How's it going? How did it went with the exam, by the way? Okay, so 4 over 2 is fine. What if we have this? No, 4, 8. This is 9 over 2. Floored will be 4. 1, 2, 3, 4. The repetition, I guess the repetition has to be like a multiple of the length as well. So we could actually break down the number of digits into factors, like prime factors, maybe, and only check those lengths. That would be optimization. Whatever. Let's just do half. That should be fine. Like 4 in like this wouldn't even work at this point. Anyway. Yeah. Okay, that's just something that I thought about there. Okay, so let's not think about optimization then. It's never like that. Never like what? Compare slice. Oh, hang on. Okay, I have like half an hour or something. Yeah, half an hour. Let's see. You take the entire ID. Sorry, could you give me a bit more context? Because I'm not sure what you're referring to. Okay, yeah, there's a little bit more to do here. So compare slice will be I plus I rep length, but I also need to be increased by rep length -1 so that we properly step through. Because if we have length 2, we should increase I by 2 and not 1. So increase I by an extra 1 here. Actually, can you even do that? No, I don't think you can. We have to have like an I here, which starts at rep length. And then we have like a while. I is less than, wait, I is less than this. And then we don't have a capture, we have a continuation expression, which is that you are added like this. There we go. This number isn't invalid. Yeah, this one? No, I know, but I was just walking through how the algorithm would work here. Like, if we have, like, my point was this, like, if we have a bunch of 2s, it would do like a whole bunch of unnecessary checks, basically, because we have a 2 here, so we could somehow kind of realize that, oh, there's only 2s, but then there's 1 4 at the end. So at that point, like, maybe you could improve the algorithm a little bit to kind of, you know, understand that, so we don't have to do the checks, like first you check for this one and that will go all the way to the end and there's like an invalid number. Okay, then we try the next one. So we try this one and then we check all the way to the end. Oh, that's not valid. So we check the next one, you know, and so on. Also, maybe it's also more optimized if we check first. We kind of swap the polarity. So first we check the first one, or we take the repetition of the first one here. We check the last one first, and if that's invalid, or let's say this is invalid, we do something like this. So here we check we take this, checking it against that. Yeah, that works. Check against that. That works. That works. And then we get to an error here because just because of how humans would maybe do this example here, I don't know. Anyway, whatever. The stupid optimization thoughts here. Okay, so we have like compare slice. Yes, and we compare against the compare slice, and if that is not equal, we need to now test the next one. And if we get over here, that means that we've actually found, no wait, we will break. Actually, we could do this. This is the 4. Oh, you can't have 4 as a, so this is the outer. So what we'll do is we'll continue outer. That will kind of go to here and continue here. But if we get here, that means we have actually gone through everything and found repetition. So here we should return false, because we've gone through everything in this while to find, you know, everything is equal. So everything is repeated, so we return false. However, if we go out here, then that means we didn't find any repetitions. So we should return true. Actually, the other way around. True for invalid, false. Wait. Hang on. We did. So if we found... Okay. If this went through, we are repeated all the way through, so it's an invalid ID. Yes. If we exhaust everything, that means we didn't find an invalid ID, so we should return false. Yes. Okay. Now let's see how slow this runs and if it's correct. Let's do that. Or if we get an error. Try. Index out of bounds, index 8, length 7. Here, where was it? Compare likes ID S. So which index? Okay, so this should go to length. Wait, shouldn't this go to like... Let's, I guess, yeah, okay, we'll remove rep length. So then, I'm just gonna go through. There could be like a one-off error here. So length and then negative rep length. What if it's 1? Then this should be like -1, I think. Yeah, it's slow. I think it's easy to get the length of the string. Yeah, I mean, yeah. I did the max length before I decided to make a string, so... And then I just didn't change it. Oh, integer overflow? What? Okay, let's change to U64s. U64s. All right. It's super slow. It's probably like the allocations probably have to do with it. I mean, we could try to see like well, let's just see if it runs. What? Integer overflow again? Okay, I want to do one thing to speed it up a little bit. So basically, let us do I want to do like analyze puzzle, analyze result. Max digits. We get contents. We will split it and blah 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 blah. We don't need to parse it. We will say max digits is zero, and then max digits equal to the maximum of max digits, and first ID s length, second ID s length. And then we return max digits. Okay, so we're analyzing the puzzle. Now comes the cool part here. In Zig, you can actually like comp time analyze things. So basically I will hopefully we'll get this to work here. So this will be like analyze result, analyze results. It's gonna be you know, comp time. Well, it's gonna be analyze puzzle, and the contents is gonna be embed file 2.input, and there now we have a comp time analyze result. And let's get rid of the error. I'm not sure if you can have errors. Yeah, I'm just gonna catch to say let's just catch okay. So now we should have an analyzed result here, and then you can be logged out here, or actually we could compile log this. Set evil branch quota. Right, so now you will be okay. Yeah, we can do like comp time print. And now we get this, max digits is 10. Okay, so what do we need this for? Well, we're gonna use that over here somewhere. So we don't allocate, we actually create an array with max digits length, like bytes in it. Which we then will use, now instead of alloc print, we'll use buff print, which will print the number into here. And since we know the max digits, we know that it will never overflow this array. Because we're like in the compile time step, it will load the file, analyze the maximum digits of the range of the IDs, and then we'll just use it here. So yeah, and then we'll do this, and then we'll get the actual, okay, so this is actually the buffer. We don't have an allocator, instead we have a buffer now. And then we can get the slice like this. Yeah. So now we don't have to deal with allocations or anything. No syscalls. We just put this thing on the stack now instead. Pointer to a constant 10. Oh yeah, this needs to be a var. There we go. Okay, now we get here a lot faster. We get to the integer overflow error a lot faster. And I guess then you can say that the downside of this approach is that you have to kind of know the result beforehand. But I mean, you could set like a hard limit of how many digits is supposed to be there. But now we can actually analyze the result and put the max digits. So just a nice little exercise there for some comp time stuff. Because this is like, you can't define an array with a runtime known length. It has to be comp time known. But now we're kind of guaranteeing that we get that. Okay, so what kind of overflow error are we getting? Integer overflow here. Max length. I would stick to splitting the string in half. Okay. How do you mean? Like, because surely you would have to split it. Like, because you have to, like, let's say the first iteration, we check only the 2. If 2 repeats. Actually, if the length is odd, it can't ever repeat, right? No, it can if it's all like the same number. Like if it's 111, then it repeats. But if it's like, if it has 1, if it's an odd number and 1 is different from the other, it doesn't repeat, right? It has to be all the same. Because this doesn't, it's not a palindrome checker. Yeah. The only way for odd, so we could have 2 different algorithms. We could have one for odd, we could have one for even, but because the odd ones are even, that they should be faster. So but if you split it in half, let's say you have like 2, 2, 3, 2, 2, 3, or 3. What if the repetition is... No, wait, you can. Right, this is an odd number. Yeah, you can have, just not that one that I showed you. You can have this repetition. It has to be a multiple of the length of the, like the number of digits. This is invalid here. So that's what I think. Like, you can't just split this in half because it's odd length. You basically, what I'm doing is I'm basically splitting it in multiples of the length that I'm currently checking. So first I'm only checking one number, then I split the whole thing into ones. Then I check two numbers and I split the whole thing into twos. Then I check three numbers and so on. No, this is invalid, right? Because it's a repetition of 2, 2, 3. 2, 2, 3, 2, 2, 3, 2, 2, 3. That has to be invalid, right? Or did I understand it wrong? Yeah, it even says in the question here, 1, 2, 3, 1, 2, 3, 1, 2, 3 twice would be invalid. Wait, it says repeated twice. What the hell? How can I miss this? Okay, I missed that part. It says twice everywhere. Okay, now I see it. Wait, which is made only of some sequence of digits repeated twice. Oh, I see why you're saying that now. I was thinking you had to look for like repetition of the whole thing, like it could be any number of repetitions. I didn't read properly. My bad. Okay. Right. Whatever, I'm not gonna edit the rules there. Okay, well then it does make a lot of sense. Splitting it is splitting it into. Okay, yeah. Should I just nuke this whole thing? Okay, let's just redo this. Okay, let's have like first half is 0. Actually, okay, wait. So that means that if it's an odd number, it can't actually be repeated. Yeah, okay. So if this 2 is 0, we will, or 1, we will return false. Okay, and then we have first half is gonna be actually we don't need you. First half is gonna be IDS 0 to length over 2, and then the second half is this. Thank you for the help, by the way. To the end. So if it's 4 length, this goes to 0 to and then to Yeah. Okay. Now we just need to check if they are equal, I guess. So basically, right? Isn't that true? Or not? Well, yeah, if they're equal. I'm not confident, because every time I did this it was wrong almost last time. No, that's not correct. Did I type it right? 639. Okay, another thing I want to make sure is that we don't get like empty strings here. No, but we should not have empty strings, because then this would have failed. If this invalid, increase the thing. This means it's valid, yes. Yeah, these are slices of U8 where we take the original, like we take the slice of the number that we have here. So, okay, we get a number in. We make a buffer that has like, you can hold any ID in here. We create an ID slice with buff print that just formats the number into the to the string here, to this buffer. So this is a slice. So basically, if when ID is 1, that means that IDS is 1, and so on. ID is like, then this is gonna be that. And we then check if the length, that is the number of digits here, is odd. We return false, because then it's valid. Then we're checking here, like we're taking the first half, which is length over 2. It's a multiple of 2, so we should be able to, actually, let's make sure we do a div exact here. So half length is this going to be different? I don't think so, no. And then we're just checking if the first half is equal to the second half. Then it repeats twice, right? 31313902223. That looks correct. Okay, is something wrong with this part? Wait, oh my god, okay. This is wrong. I thought we were supposed to add up like the number of invalid IDs. We're supposed to add up the actual IDs themselves. I think. Let's get rid of this. Okay, now we get like a number that is a little bit more than like the actual example they gave there. I was like, wow, that's a lot of crunching there, but it was just adding the thing. But that's not right either, so okay. Did I copy it correctly? Yeah. Are you checking including last ID plus 1? I mean, we could do a test. Let's do is invalid ID. So this would be like std testing, try testing expect equal. So what would then 11 would be, well, expect. This would be invalid, and this would be invalid, and then this would not be invalid, and this would be invalid, and then this would not be invalid. Oh yeah, we need to try this. Wait, why do we need to try this now? We don't. This doesn't need to be tried. Okay, it does need to be tried. I'm just lying to you, straight to your face. Okay, that works. Test A works. Test B. Let's have an input. Just add 2 so that we, and then we have like expected is gonna be a U64, and it's gonna be like 11 and 22, so 11 plus 22, and then we'll do try, then we'll do like results. It's going to be solve for input. And then we're going to do expect equal expected result. And that's false because, as you say, we probably are not checking the last one. This needs to be included, yeah, +1. Good catch. There we go. Now we should get a different number here. Yeah. Let's try that. Yay! All right. Big helps from you there, Ian. We got to it. All right. Thank you. Cool. All right, and then there's like part 2, but I don't have time for that actually. I just ran out of time. I have something else I gotta do now, so yeah, I will have to go now. So yeah, thank you very much for watching me. So I will be back tomorrow, hopefully. We'll see. But yeah, have a nice day, and I'll see you later. Bye bye.